Gates 2022 set 2. Okay, question number 47. This particular question has multiple answers rather than the single answer. So kindly read this question and just guess it, like what are the correct options here. So this is related to the critical flow. uh, this is critical related to the critical flow. Just guess it, like how we can solve this, what are the options. So let me read the question for you. Water is flowing in a horizontal, frictionless, rectangular channel. Okay, a smooth hump is built. So let's say, assume this is a channel. This is a channel bed. Okay, and a hump is built, which has a height of delta z. Okay, fine. And it height gradually increase to reach to, so sorry, this is not a sudden, so they have built it in such a way like a sudden increase. Okay, so this is a way they constructed. So the height is gradually increased to reach a choked condition. Kindly remember the choked condition. The choked condition means delta z is equal to delta z max. Okay, I'll tell you what is the delta z max. Okay, the depth of water at this section y2, and that is upstream section is y1. Suppose, let's say, if the flow is taking place over this particular section, this is y1, and this can be either, in this case, or like based on the flow condition it will change. Let's say, for the sake of this is y2, this is y1. So now the correct statement or statements for the choked or unchoked condition in the channel are. So this is a scenario. Now just guess it, what are the options, are what options are correct here. The first option is, in a choked condition, y1 decreases if the flow is supercritical and increases if the flow is subcritical. Okay, let me tell you what is the choked flow. Okay, suppose suppose okay, I think this I have shown you. This is a specific energy curve. This is specific energy curve, and this is a graph curve between discharge and the depth. Okay, discharge and depth. Okay, so as all of you know, this is a specific energy curve, and this is a minimum specific energy required to take the to take the flow takes required to flow takes place. Okay, and this particular this curve has two sections. One is subcritical and the supercritical. Okay, let's say draw one vertical line like this. Let's say this we mention as E1. Let's say, for example, here, let's take the same question. This is a channel bed. Now construct a ramp. Okay, this is a ramp. This is a delta z max. Okay, so at some distance it will be same, it will be delta z only. Let's say this is a section 1, and maybe let's say this is a section 2, where z equal to z max. Let's say if I calculate, this is E1 and this is E2. So as according to specific energy principle, E1 equal to E2 plus delta z max, or z, if we go at the second section 2. Okay, so suppose, let's say, if we draw a line correspond to value of E1, this is E1 and this is E2. Okay, okay, this is E2, and correspondingly we will have one depth. Correspondingly we will have depths. Let's say this is a y1 y1, this is y2 y1, this is y1 2, and this is y2 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 dash. Okay, So as you know, all of you know, this for same specific energy we have alternative depths. Okay, let me read the options first. Okay. Oh, there's one term here. Hooked arms. Okay, this is the case. Okay, so as you increasing the height of this hump, okay, as you increase the height of the hump, this particular line moves towards this critical energy position. So after certain height, after certain raise in the hump, let's say when we reach to the Z max, the energy available at this particular flow is E minimum. Suppose if we raise this particular bed even further, the the discharge won't be the same. If you see, this is for a constant Q, and the discharge won't be the same, and the specific energy curve will shift. Either it will shift towards right, it will shift towards right. This will become E minimum. Okay, to maintain this, to maintain the discharge. Okay, so that particular condition is called choke flow. When the choke flow happens, when the transaction, the depth is more than the Z max, such that the specific energy for a given constant Q is not available. During that case, the flow condition is called as a choke flow. Okay, now read the options. Let's see. Let's look at the option C. Okay, in unchoked condition means this curve will be valid. This blue color curve will be valid. The blue color curve will be valid. So this is a for the same constant Q. For a choked condition, this Q will become Q dash. Okay. In the choked condition, the discharge will change. In unchoked condition, the Y1 remains unaffected when the flow is supercritical or subcritical. Okay. Suppose let's say this is a Y1. Suppose let's say you raise this pump to some delta Z. Okay, this is a flow at Y1. Now let's say the flow is subcritical. What will happen? The discharge will reduce and the depth will decrease. Okay, and suppose if the flow is supercritical, the depth will increase like this. So it does not alter the upstream depth. So option C is correct. So in unchoked condition, Y1 remains unaffected when the flow is supercritical or subcritical. Okay. In a choked condition, what happens? Like, let me put it in the correct words. In a choked condition, for the flow to be possible, okay, for the choked condition, the upstream flow condition must change. Okay, in the choked condition, let me write it in here so that it will be clear for you. In choked condition, the upstream flow condition must change. Okay, that is the E1 is the initial one, and from E1 it will increase to E1 dash. So in this condition, the depth will change. Okay, and such a way that E2 will become equal to E minimum. Okay, E2 will become equal to E minimum. What I mean here, let's say this is a specific energy curve. This is a curve, initial curve. Sorry, it's not asymptotic. This is the initial curve, one one situation. Now let's say if the choked flow happen, the curve will shift towards right. Okay, and this is, let's say, E minimum, and this is E2. Now the curve will shift in such a way that the E2 will be equal to E minimum, and this is E1, and this will go to E dash 1. This is E1. Maybe this is slightly confusing for you. Don't worry, you will get to it. It's a simple, straightforward only. Okay, this is initial, this is a secondary. Okay, this is for a choked condition. Okay, so let's say this is a two regions, super and sub. So let's read the first option. In choked condition, y1 decreases if the flow is supercritical. Okay, please bear with my drawings. This is super, this is sub. This is E1, this is E1 dash, as I mentioned. Now let's say, so this is like in this manner, not sorry for this thing. This will increase in this way. So the y1 decreases if the flow is supercritical and increases if the flow is correct. Suppose as E1 is shifted to E1 dash, this the depth again is further decreases. If you correctly remember, this curve will be asymptotic to x axis, so the depth will decrease. Whereas in supercritical, the depth will increase. Okay, the depth will be increased for the same. So let's say here it will be here, but for the E1 the depth is here. So option 1 also correct. For in a choked condition, y2 is equal to critical depth if the flow is supercritical and subcritical. Thus I have mentioned, in the choked condition, your upstream flow condition must change such that E1 equal to become E1 dash and E2 become E minimum, and correspond E minimum is a critical state of flow. Okay, so option or this option also correct. So now so far we have shown that three options are correct. What is the third option? Fourth option, in a choked condition, y1 increases if the flow is supercritical. This is wrong. Okay, this is wrong. So correct answer options are A, comma B, comma C. Okay, so see, this is very simple if you know this particular diagram only. If you know the specific energy curve. So specific energy curve, like see, when you increase the hump after certain distance, like